If we want to investigate a sequence further, for example, if we wanted to find, say, the 50th term of the sequence, we're going to need to work out the nth term. So we need to be able to work out the nth term of a quadratic sequence. This is the method. Firstly, we need to recognize that the nth term is going to be of the form an squared plus bn plus c. This should remind you of what we've done on quadratic equations, because every quadratic equation has the form ax squared plus bx plus c, so it makes sense that a quadratic sequence will be similar. A, which is the coefficient of the n squared term, is half of the second difference. And then you need to complete this table. The table looks really complicated, but the only thing we haven't seen yet is this Tn notation. Tn is just a way of writing the nth term. So Tn is the nth term. So if I wrote t and then a little 1 at the bottom, that would be the first term. So in this sequence, that would be 2. And t2 would be the second term, which is 9. t3 would be 18, and so on. It's just a notation that we need. So we're going to fill the table in. We know that t1 is equal to 2, so I'm just going to fill that in. 2, t2 is 9, 18, 29, 42, and so on. We then need to work out a. To work out a, we need to work out the second difference. So if we look at the first difference, first of all, 2 to 9, we're adding 7. 9 to 18, we are adding 9. 18 to 29, we're adding 11. So we can see pretty clearly what the second difference is going to be. So 29 to 42, if we add 10, we get 39. So we're adding 13. And we can see that the second difference is going to be 2, because to get from 7 to 9 we add 2, 9 to 11 we add 2, and so on. So we can say that the second difference, a, is equal to 2. We can see that the second difference is 2. A, we just need to learn this, is half of the second difference. So we can say a is half of 2, which is just 1. So we can say a is 1. So an squared, when n is 1, is going to be 1 times 1 squared, which is 1. When n is 2, we have 1 times 2 squared. 2 squared is 4, so we have 4. We have 9, 16, 25, because it's very simple when a is 1. Now we just need to work out the difference. So Tn, take away an squared. So we do the top row, take away the second row. 2 take away 1 is 1. 9 take away 4 is 5. 8 and take away 9 is 9. 29 take away 16. 19, we're going to get 13. 42 take away 25. We're going to get 3, 12. 7, we get 17. The sequence in the third row, as we can see, 1, 5, 9, 13, 17, and so on, is going to be a linear sequence, and we can see that it is. We're adding 4 every time. And the common difference of that sequence is going to be b, and the constant is going to be c. So basically, we look at the sequence in the third row, 1, 5, 9, 13, and so on. And we work out its nth term. So as before, from the previous video on linear nth term, the common difference, or the first difference, is 4. And we can see that's constant. We know the 4 times table goes up in 4s. 4, 8, 12, 16, and so on. To get from 4 to 1, we take away 3. 8 to 5, take away 3. 12 to 9, take away 3, and so on. So the nth term is 4n, take away 3. So we can say that b is 4, because that's the number by the n. And we can say c is minus 3. Finally, this gives us the nth term of the quadratic sequence as an squared plus bn plus c a is 1, so we have n squared. B was 4, so we have n squared plus 4n, and then c was minus 3, so minus 3. So that is the nth term of the sequence which we started with. Let's try another example. We want to find the nth term of this sequence, 1, 5, 17, 37, and so on. So firstly, let's work out the second difference, so we can work out a. So we're adding 4, then we're adding 12, then we're adding, I want to say 20, 17, yeah, 20. Then we're adding 28. So we can see that the second difference is going to be 8, because to get from 4 to 12 you add 8, 12 to 20 you add 8, and so on. So we can say straight away that a is going to be half of 8, half the second difference, which is 4. So we know that the nth term will have 4n squared in it. We now fill in the table. We know T1, the first term is 1, second term 5, third term 17, and so on. We just fill that in. We know A is 4. 4 times 1 squared is going to be, 4 times 1 squared is 4. 4 times 2 squared, 2 squared is 4, 4 fours are 16. 4 times 3 squared, 3 squared is 9, times 4 is 36. 4 times 4 squared is going to be 64, because 4 cubed is 64. And 4 times 5 squared, well, 5 squared is 100. 5 squared is 25. 4 25s are 100. We now work out Tn take away an squared. 1 take away 4 is minus 3. 5 take away 16 is minus 11. 17 take away 36, so to do that I would do 36 take away 17. So that's going to be 19, or minus 19, if you do 17 take away 36. 37 take away 64, 60 take away 30. 27, so minus 27. Check that, let's do 7. Yeah. And 65 take away 100 is minus 35. So we can see that we have a linear sequence in the bottom row, minus 3, minus 11, minus 19, and so on. We can see that we're going down in 8. So the first difference, or the common difference, I should say, is minus 8. That's the only difference because it's linear. We can see that the nth term is going to be given by, so let's just work it out first. If we consider minus 8, minus 16, minus 24, to get from minus 8 to minus 3, we need to add 5. So the nth term for that last row, that linear sequence, is going to be minus 8n plus 5. Minus 8 plus 5 is minus 3. Minus 16 plus 5 is minus 11, and so on. So the bottom row has nth term minus 8n plus 5, which means that B is minus 8 and C is 5. We compare it with the an squared plus bn plus c formula. It should be clear. So that leaves the nth term as 4n squared minus 8n plus 5. And at GCSE level, you're unlikely to get one that difficult, so if you can follow that example, you should have no problems with this topic. Here are some questions for you to try. Please pause the video now and have a go at them, and when you're ready for the answers, press play. Here are the answers.